Hello, everyone. This is Rona Palmer from eMaint Enterprises. I'd like to thank you for joining us today for this month's Best Practices webinar. And for those of you who are not familiar with eMaint, we're a CMMS software provider and provide a whole host of different types of webinars and educational offerings. But our Best Practices webinar series really focus more on maintenance strategies and not specifically on our CMMS software features. And we invite in speakers from a variety of different industries who offer what we believe are complementary products and services, and we invite them to share their knowledge. And one such person is Pete Tecos, who I'm pleased to have with us today. And Pete is the Executive Vice President of 5ME, and he's going to be presenting today's topic, Best Practices for Monitoring Asset Performance and Improving Productivity. And thanks, Pete. Are you there with me?
Indeed I am, and thank you so much for the kind introduction, Rona. We really appreciate the opportunity to be part of the eMaint Best Practices series.
Well, thanks, Pete. And I'd like to just give our listeners who may not know Pete a little background, and also say I know Pete had to take some time out of a very busy schedule and rearrange some things to not disappoint our listeners today, and we really do appreciate that. And Pete spent the last 25 years in the discrete manufacturing industry segment working with robotics, CNCs, and other forms of automation because he is an electrical engineer by background. More recently, he's really been focused on software solutions, the Internet of Things, Industry 4.0, and through platforms such as what 5ME provides, kind of really helping clients liberate data from their plant floor so that they can be more efficient, productive, and profitable in the long term. So, Pete, while we had a very large number of registrants today because this is such a, important topic, and you've been in this industry for, several decades even, and maybe you can tell us some of the recent trends that you've seen that, that prompted you to want to put together this particular topic that you're sharing today.
Absolutely, Rona. Thank you for that opportunity. Like everyone on this call, I think we're all extremely passionate about the manufacturing industry, and it should be no surprise to anyone that over the last decade, it's been pretty punishing, especially in the discrete manufacturing sector. We've been facing all sorts of challenges, diminishing skilled workforce, be it people, operators that can run machines, or skilled manufacturing engineers. We've been subjected to outrageous global competition. Companies always opting to look for a lower cost labor solution, which really puts pressure on domestic manufacturers. And because companies like 5ME and eMaint are so passionate about the manufacturing industry, we want to do whatever we can to help domestic suppliers and global suppliers become more competitive, really streamline their operations, look for opportunities to become more efficient, eliminate waste, with the ultimate goal of building a profitable, sustainable, and globally competitive business.
And well, those are worthy goals indeed that I'm sure many of our listeners share. So before I turn things over to Pete to get into the heart of his presentation, a few quick housekeeping items. I have all of our attendees, the phones are muted because we are recording today's session, and I'll be sharing a recording with all of our listeners today so that you can refer back to it or share it with your team. Pete has graciously agreed to provide a PDF of his slide deck today to interested parties, and there'll be a survey at the end of the presentation asking if you'd like to receive a copy. So if you do answer that survey, we'd be happy to, Pete will be happy to send you a copy. And let's see, also Pete has agreed to stay at the end of the presentation and answer as many questions as time permits. But if you please feel free to type your questions at any time into the questions feature in your GoToWebinar panel, and I'll be happy to read them to Pete at the end of his presentation. So with that, I'll turn it over to you, Pete, to take it from here.
Great. Thank you so much. So as we migrate here to the first slide, I talked about the effects of global competition and how that's really having an impact on all of us in manufacturing. And so, most businesses are affected by global competition or competition in general. That competition could be around the corner, in the next town or state, nationwide, or even across the globe. And, that puts you at an impasse. Companies need to decide how are they going to compete across a number of customer values. Do you compete based on price, delivery, quality, or features? What's certain is that your customers are constantly being offered more choice, and your business must continuously improve in order to grow or even to maintain its current competitive position. So a primary metric that's used to compare businesses is their performance with return on total capital. And the stock market pays close attention to this metric because it shows how well a management team uses its assets. And to improve ROTC, you can either increase profit or you can reduce the amount of capital used in your business. To increase the profit, you have to see an increase in revenue or lower costs. To increase revenue, you either have to sell more to new or existing customers or you have to raise your price. However, in this competitive environment, it's going to be very difficult to raise price without providing some significant additional value. In fact, year-over-year savings are now part of many preferred supplier agreements. So reducing cost is sometimes the easier and more strategic path rather than increasing revenue, especially if a business has not paid particular attention to uncovering waste in the past. To reduce capital requirements, a business must reduce either fixed capital investment or reduce the need for working capital. Reducing fixed capital means putting off investments for things like machine tools and buildings or even disposing of some of the existing assets. Reducing working capital means reducing inventory and other wastes. The bottom line is a business must learn to do more with less and attacking all these areas to achieve a premium return on total capital. The market is going to reward a premium performance with a premium stock price, which will satisfy investors and other stakeholders. And as we will state, overall equipment effectiveness, or OEE, is a tool that is focused on reducing the amount of capital used in a business by uncovering hidden capacity in the factory that is currently consumed in a variety of forms of waste. And Rona, you might want to poll the team right now for, is anybody out there currently using OEE or thinking about it?
Sure. So that brings us to our first poll question. We have two today, and if you don't mind just letting us know, there's no wrong answers here. We'll only share the data in aggregate, but kind of let us know, are you currently today tracking OEE? Let us know yes or no, maybe you have plans to, or no, you're really not planning to. You don't believe it's an important metric for your business. So looks like we've had about 2/3 of the votes in, and so I'll give our listeners a few more seconds to weigh in. All right, up to about 80%. Okay, I'm going to go ahead and share the results. So it looks like 21% today do track OEE, 55% don't but have plans to, and then 24% are saying they don't currently and don't plan to in the future. All right, so I'm going to turn things back to you.
Great. So, we introduced the concept of OEE and the concept of reducing waste. I want to try to monetize the value of reducing waste. And here's an example, a very simple financial statement on an organization. On the left-hand side, let's say that organization is doing $100 million in sales. It's got $70 million in costs due to direct labor and materials. It leaves them with a contribution margin of $30 million. You have another $20 million in fixed costs and overhead, leaving you with a profit of $10 million. Now, let's take a look at what the value of reducing waste is all about. Let's just say I can take a small chunk out of my costs with respect to direct labor and materials. Perhaps using OEE and identifying areas where we can be more efficient, I can eliminate some overtime and take away some costs out of that direct labor. And also in monitoring OEE, I find ways where I can perhaps reduce scrap. Now here's really the amazing thing about reducing waste. When you take waste out of the picture, that savings drops straight to the bottom line. So in this example, we can see that only a 7% reduction in waste results in a 50% increase in profit. And that's just, huge, tremendous impact on the bottom line of the business. And that's why taking waste out of the system is so important. So, let's talk about how do we do that? How do I identify opportunities to remove waste? And it really all filters down to the collection of data. Until you understand what's happening in your facility, it's hard to make any improvements. Many successful businesses are motivated to have a continuous improvement program, striving to improve processes that impact the customer. And that could be a Six Sigma program, it could be a TPM or Total Productive Maintenance program, lean manufacturing, or a host of other acronyms. But the most effective toolkits are all based on one thing, and that's data. You need to have a data-driven process. Most projects start with data collection to determine the current situation, or the baseline, the benchmark, to establish the actual rather than the perceived performance. And then trying to make improvements without data and analysis is very risky, as I'm soon going to discuss. Many companies understand the need for data collection, and many are doing it manually, and I'm going to discuss some of the challenges with that methodology. I'm then going to discuss the benefits of automated data collection, including data integrity and timeliness, as well as efficiency. And finally, we're going to discuss some of the reporting tools that turn data into actionable information in real time, give you the ability to really impact your business based on real-time data exchange. So we talked about kind of the data paradigm. We can't improve what we don't measure. And you may have already experienced the fact that it's very difficult, both politically and practically, to improve processes unless you have a robust measurement system in place. Without credible data, it's difficult to convince a management team to invest time, materials, or money to achieve the necessary improvements you're recommending. And without data and the analysis to discover the root causes of problems, any improvements achieved may only work temporarily or only for unique cases. So in a presentation not too long ago on the direction of lean manufacturing, James Womack commented on his observations on numerous companies that are trying to improve processes. And he noted that Lean, Six Sigma, TPM, theory of constraints, the Toyota production system, and a host of other popular manufacturing toolkits all share the goal of searching for the perfect process through continuous improvement. But they only differ in their starting point and emphasis. Womack is known for a study of the Toyota production system, the original lean manufacturing implementation. And during his presentation, he offered an interesting comment on lean at Toyota. He confirmed that lean has been applied at Toyota in every aspect of their business but one. They use lean in manufacturing, operations, finance, administration, and in every department except sales, the part of the process the customer gets to experience personally. So even for the best, the message here is that even for the best, there's always room for significant improvement, and that's why it's called continuous improvement. It's a never-ending journey. So, what does the perfect process look like? So, let's try to define what the perfect process is. First, it's valuable, meaning there's no waste. It includes nothing that the customer isn't willing to pay for. It is also capable. It gives good results every time, from the first setup part to the last production part. It's available, so it'll work when you need it. That means that the machine, the tooling, the materials, and the labor are all available at the right time. The process needs to be adequate, meaning that it can produce at the required production rate with no bottlenecks. And finally, it needs to be flexible, so it can accommodate quick changeovers from one product to the next. So formal continuous improvement processes typically have a cyclical multi-step process. If you're doing Six Sigma, you're familiar with DMAIC, define, measure, analyze, improve, control, or Deming's plan, do, check, act methodologies. So You know, in Six Sigma world, it uses data about the existing process in the measure and analyze phase, and data about the improved process in the control phase. And similarly, the plan, do, check, act methodology uses data at the latter end of the plan step to verify or revise the original problem statement, and then to identify root causes. And using the data collected from the actual process can strip away hearsay, prejudice, and intuition, and improve the likelihood that a solution will be effective. However, it can be very challenging to collect sufficient quantities of relevant data to characterize a process. And you need to give particular attention to ensure that the data collected is free from bias and other measurement system errors. Often, the simple act of collecting data can change behaviors in such a way that it distorts the results. So, finding problems in processes can be similar to a detective solving a crime. And as Sherlock Holmes points out, without data, we can be tempted to assume that current are similar to other situations that we've experienced. Then we start twisting the facts to suit these preconceptions. Therefore, it's vital to collect data effectively to ensure the underlying problems are treated rather than just the surface symptoms. Many of you, I'm sure, are familiar with Edward Deming, the father of quality improvement in Japan and eventually in the United States. And he demonstrated the effects of what he called tampering in his famous funnel experiment. And that was all about making changes based on pure intuition that can actually make things worse rather than better. And let me just give you an example of what this experiment did. So in the baseline experiment, a funnel was placed directly over a target, and a number of glass marbles were dropped into the funnel and allowed to roll freely. And the distance from the target to the position of each marble was measured, and descriptive statistics were then calculated. In the second step of the experiment, the position of the funnel was adjusted after each marble in an attempt to compensate for the distance that the marble rolls after being dropped. And this intuitive solution actually made the problem worse. And Deming's point was that in all processes have variation. And it's really important to understand what variation can be attributed to the system's inherent capabilities and what variation is caused by outside or unexpected disturbances. So implementing process improvements without really understanding root causes in the system's basic capability can be unproductive and actually can take you in the wrong direction. So it can be challenging to decide on what data needs to be collected and how that data needs to be grouped and analyzed in order to produce something that's meaningful and, more importantly, accurate. And OEE is a key measurement for doing that. And OEE is the product of availability, performance, and quality. It focuses on those three primary metrics. So from an availability perspective, is the machine making parts per the schedule? Or, is it in the middle of a changeover, or is it not available for some type of electrical or mechanical malfunction? Next is performance. Is the machine making parts at rate, or is it constantly being slowed down to take care of material variances, as an example, or does it have to constantly be interrupted to change inserts? And then finally, there's quality. What is our yield? Are we turning out good parts all the time? Are we scrapping parts during setup? Are all the parts in the production run to the specifications or not? Sadly, most companies do not know the answers to these questions, even if they track the status of the machine operation and they have insufficient insight into the root causes that drive these metrics. All data collected should be relevant to the goals of the organization, and everyone in the organization should know the impact on the business when a metric goes up or down. OEE metrics of availability, performance, and quality can be easily understood at all levels of the organization, and they have a direct impact on ROTC, on profitability, and on the overall share price or performance of the business. Getting started with OEE, when implementing OEE metrics, it's important to collect information that will help determine the root causes of problems so patterns and failures can be uncovered. And one way to visualize problems and their root causes is to construct a cause and effect or a fishbone diagram. Causes can be grouped into a tree to improve understanding. So failure modes and effects analysis, or FMEA studies, can also be used to prioritize the most relevant data that you need to collect. Probable causes and effects related to the process can then be grouped in categories such as materials, methods, manpower, measurements, machines, and environment or Mother Nature. And that's part of the 5 M's that directly affect manufacturing efficiency. So let's talk about how do we collect this data. There's a few different methodologies. The first is manual data collection. And right now, many companies are trying to collect data today using manual or paper and pencil methods. And while it comes with some challenges, it's certainly better than not collecting any data at all. When you collect data manually, it's really important to train your team on good data collection techniques and to provide them the tools that allow the data to be collected easily and, more important, consistently. You don't want to introduce bias. Metrics such as counting parts produced are straightforward. However, counting defects can be confusing. And for example, multiple defects on one part counted individually, or do they just count as one bad part? So when you enter those areas that open things up for interpretation, that's when you start to get yourself in trouble with manual data collection. Metrics that require measurement equipment are subject to application variation and interpretation as well. So training and calibration will minimize those effects, and well-designed forms will minimize data entry errors, and a clean, well-lit workstation will contribute to the overall success of your manual data collection program. If possible, you want to collect values or variable data and avoid the temptation to simplify everything into classification or attributes data, such as good or bad. Values can be compared with other variables, such as the time of day, or the temperature, or of the temperature of the shop, to discover any important correlations that might be going on. Thermal growth could attribute to going out of spec or out of tolerance, as an example. But there are always challenges with manual data collection. The key challenge to manual data collection is ensuring that the data is an accurate representation of the process, and that you're allowing for meaningful analysis. Without adequate employee training and motivation, there can be significant differences with how individuals collect the data, and variability in data collection skew the results. That's the last thing you want. Poor forms or inadequate training will lead to data entry errors. And more likely, the actual process of data collection will change behaviors in such a way that the typical process is not being represented. Operators could slow down or speed up depending on their motivation. Unless the data collection is consistent and actually part of their process, they may even forget to enter that data. So the resources required for recording, collecting, data entering, analyzing manual data may preclude an opportunity for actually improving the process, because you're spending so much of your time and resources in the data collection process that you're not allowed to give the adequate amount of time to the analysis so you can fix your problems. Sometimes it's virtually impossible to complete the cycle in a timely manner so that actions can be taken to correct the problems before they impact your business. So, I think in discussing those last two slides, I think you can all see that manual data collection, while better than not collecting at all, definitely has its limitations, and it's often subject to errors and bias. And if you start with bad data, you're most likely going to produce bad analysis and implement less effective improvements. So it would be more valuable if data could be collected automatically, and that would allow you to free up resources to focus on the more important aspects of analysis and process improvement. So let's talk about automated data collection. And in the last decade or so, controls technology has come such a long way, and the modern control is really at the center of most manufacturing operations. It's very capable. It can provide rich electronic data on a wide range of processes and events. Ethernet has become an industry standard for connectivity, and many machines already have a connection going to a PC right next to the machine, or in ideal cases, those machines are already connected to a plant network. So electronic data collection not only overcomes the errors and the bias of manual data collection, but it also fully automates the data entry process, and in some cases, even the analysis of the data. So that way, information can be shared across business functions, and corrective actions can take place in almost real time. And Rona, this might be a good time to go to that second poll question: is who is monitoring their assets, electronically or digitally at this point?
Okay, cool. Our last poll question, Pete is just asking, how many of you today use some form of digital monitoring or data collection, or versus some other methods? All right, so we'll let everybody weigh in. Again, we're just collecting this in aggregate. There's no wrong answers here. And we'll leave it open a few more minutes or a few more seconds, see where we stand. All right, looks like just about everyone. So I'll go ahead and share results. And okay, well, currently 44%, Peter, saying that they're using a digital method. 56% aren't. So just under half today are currently using digital monitoring. I don't know how that's trended or how that compares to other things you've seen in your industry.
Mm-hmm. Yeah, that's about on par with what we're seeing, in a lot of the companies that we're working with. So let's talk a little bit more about the automated data collection and Freedom, the smart manufacturing platform. So I don't know, hopefully many of you are familiar with MT Connect. MT Connect is a standard by which industrial assets communicate, and the Freedom platform is using MT Connect adapters to connect with any industrial asset. It doesn't matter what brand control, what brand machine, or what the process is. Completely agnostic to industrial assets on the plant floor. What's nice is that it does not require, our system does not require any special engineering. You don't have to change ladder logic, NC programs, or anything of that nature. It is a web browser-based system. Bottom line is, we can connect to anything on your plant floor and extract meaningful production data from them, so you can make more intelligent decisions on how to manage your facility. The typical architecture of a data collection system like Freedom, there are two main components. You have a server component, which is the data historian and the analysis portion, and then you have an asset-based interface. Again, that's based on the MT Connect protocol. So each asset will have an interface to it. There will be an Ethernet connection established to a server. That server will then harvest all the data and create all sorts of reports and analytics. Anybody who's authorized can then log onto the system and start viewing that data to improve plant management. Another thing that we're doing with companies like eMaint is driving more transparency across the enterprise of an organization. So while our core competency is tapping into those plant floor assets and extracting that critical manufacturing data, we see tremendous opportunity to take that data we've harvested and share it upstream into the ERP, MES, and CMMS areas, where those systems can make use of that data and really start to leverage data streams directly from the plant floor. When we connect to any industrial asset, there's basically three ways that can be done. For modern controls that have an Ethernet port and that have a Windows side or a PC front end to the control system, it's typically just a pure software interface. The adapter it's software that's loaded onto the Windows side of the control. It automatically gathers the data and pumps it up to the server. So that's scenario number one. In scenario number two, you may have control systems, while modern, that have an Ethernet port. Some of them are not based on a PC front end or a Windows platform. In those cases, the interface is put on a host appliance, like you see here in this picture, and that host appliance would then talk to the control using its native APIs or drivers and libraries. As an example, a FANUC I-Series non-PT front end would use this type of architecture methodology. And then the third scenario is the ability to connect to old legacy equipment. Not only controls that may not even have an Ethernet port, they could be old relay logic or manual machines, but we have still devised a way in which we can extract meaningful data from those assets, and that would be through the use of the hardware appliance you see in this picture, in which it hosts the MT Connect adapter, the interface, and we would establish discrete I/O connection into the industrial asset to access the signals that we require in order to get all the information to generate the reports and analytics within Freedom. Freedom, a couple of unique things about that software package is that it is based on industry standards, and those industry standards are driven by AMT. The first is the span time category definitions, which was based on a document written by the Association for Manufacturing Technology, which outlines what states a machine can typically be in, and I'm going to describe that in detail on the next slide. The second standard, also driven by AMT, is MT Connect. And very high level, MT Connect is an open, extensible protocol that's designed for the exchange of data between industrial automation and software applications that are used for monitoring and data analysis in an XML format. When we talk about the AMT standard, what is it telling us? And basically, it's defining these 6 span time categories, and these span time categories are the basis by which we're doing all of our analysis and reporting structure within Freedom. Starting from the left, you could be in plant shutdown mode, which means the facility is closed and nothing is available for operation, a major holiday. As an example, it could be scheduled downtime, where the facility is open, but the equipment has specifically been scheduled down in order to do some type of maintenance or retooling function. It could be in delay, yellow time. These are unexpected events that keep the equipment from being operational. And this is one of the key areas where you can really take a deep dive into some of the analytics and reports and find waste on your plant floor. The next is the repair time, the red time. This is when equipment is incapable of being in operation due to an electrical or mechanical malfunction. And then 2 forms of production time. Your blue time, which is not in cycle process time. Some people view this as the non-value add time, but still a necessary part of the production process. This is when things like setup, gauging, inspections, adjustments, replacing tooling, when those things take place. And then finally, your green time, your in-cycle time. That's when your equipment is actually running and producing parts. So this is the foundation of how we categorize the span times within Freedom. So at a very basic level, what we're doing is automatically extracting data and telling you how much of the time you're spending in each of these categories, but then also adding some really great drill downs so you can find root causes of what's actually happened in each of these categories. I'm going to show you just a few examples of screenshots from Freedom 4.0. This is a stacked bar chart, and you can look at an asset, you can look at a group of assets, you can aggregate your entire facility, and the stack bar basically breaks out by color code according to those 6 span time categories, how long the asset or group of assets was in each of the categories. So you can see just with a quick glance how much of the time you spent in cycle versus in process versus in repair. We also have a detailed summary view, and this allows you to start at a high-level overview, looking at a week's worth of time on an asset, all the way down to a resolution of just a second or so. So it gives you lots of flexibility. You can look at everything that's happened on a particular asset. It shows you a high-level overview of alarms, whether the machine was powered on or off, the part programs that were being run, cycle data, when was it in and out of cycle, and then any of the events that have been captured, whether they're delay, repair, or process related. It shows the schedule that's been set up for the facility. That's all configurable within Freedom, from single shift to 3 shift to customized shifts. And then the composite bar at the bottom kind of aggregates all that data. This other example is a top 25 alerts. And so what we can do is automatically Pareto alerts that have been generated by the control system. And if you look carefully at that graph, you'll see in the top left corner, there's tabs for count and duration. And we think it's important to be able to give multiple perspectives on data. So you can look at it by both frequency and duration. How many times did an alert happen? Or how long was I in that alert state? And it'll automatically rearrange the Pareto accordingly. And this is a really great way to share with maintenance systems like eMaint, as well as with your maintenance department, those issues that are happening within a particular machine. Gives you insight as to some of the PMs that may need to take place. Similarly, the top 25 events, Pareto's all of the events. And events are really downtime reasons that are happening on your shop floor. Again, you can look at these in multiple perspectives. And while alerts are really more of a glimpse into what needs to be happening from a maintenance perspective, the events allow you to understand process-related issues, process health, if you will, on the plant floor, so you can identify areas of waste and ways you can improve. As an example, you may be seeing over a given amount of time a lot of loss or a lot of time dedicated to part setup, or a lot of time dedicated to changing out tooling. This could prompt you for really examining your setup strategies and maybe putting in a redundant tooling strategy so that you can minimize the amount of time where that machine has to go idle in order to take care of those things. And of course, we're also monitoring OEE, and that could be done by asset, or it can be done by time period. What you're seeing here is an example of looking at it by asset. So this is multiple machines within a plant floor. You can see OEE by machine. If you look at it by period, it would aggregate all of these machines into an overall factory OEE over a given time frame. Again, in the top left-hand corner of this chart, you can see the OEE tab is lit up, but if you wanted, you can also put into the individual contributors availability, performance, and quality, so you could see how each of those are affecting the OEE and what you may need to be focusing on to make improvements. A unique feature that is available in Freedom is this report called eScore. And I talked about the fact that we like to give manufacturers the ability to view data in multiple perspectives. And the third perspective, or the third dimension that we've made available, is money. So, we've made the span time categories visible by frequency and duration, and we thought it would be really great if manufacturers could also have the flexibility of looking at these, of monetizing these gains or losses. And that's exactly what the eScore feature does. You can assign a burden rate to each of your assets, and then we'll actually, based on a configuration, you can assign a percentage rate for each of the span time categories, and we'll actually calculate, from a dollars perspective, what were the gains or losses in each span time category, and the eScore is the aggregate. So at the end of the day, you could take a look at a machine or a group of machines or your entire facility and find out, did I make money today or did I lose money? Or, in the month, you can expand the time frames. And if you didn't do so well, it'll show you exactly where the biggest losses took place, and that will allow you to go drill into some of those root cause issues and guarantee that you're focusing on the right things that are going to really move the dial in the right direction. I'd like to share with you now a few success stories using automated data collection and methodologies where we're tying together with companies like eMaint for CMMS. Cameron, which is one of our large customers, we're currently monitoring 428 assets across 25 plants in 12 countries, very extensive install base. But it started off with just a couple of plants that wanted to, dip their toe in the water with respect to monitoring equipment. And so they came to us a few years back, and their pain point was they really had a hard time just understanding their equipment from a utilization and availability perspective. As I mentioned, we're currently in an enterprise-wide implementation of eLog, but we started off with a single facility. And in that facility, there's actually two facilities co-located in one state. They put Freedom eLog in, and by harvesting that data, they were able to get a $3 million productivity and throughput improvement through their existing assets in less than 12 months, just by having better transparency into how that equipment was being utilized and how available it was, and being able to drill into the root cause issues that was robbing them of some of those efficiencies and make those corrections. So, not only did they get an ROI in less than 12 months, but they also had great cost avoidance in understanding that they didn't have to go out and buy new assets. Another very large customer for us is Caterpillar, rapidly approaching 600 assets and hundreds in process all over the world. Caterpillar had a very similar problem, understanding equipment availability and utilization. And one of the benchmark facilities was located in East Peoria. We put in Freedom eLog. Freedom is now monitoring close to 100 assets in that facility. But the punchline was, in less than 12 months, by using the data, they were able to decrease delay times by nearly 60%. They also decreased part setup time by 40%, and then also, in addition, decreased their waiting for quality lab by 31%. All those reductions in delay time ended up in those machines being in cycle almost 30% more often, and that was worth $1.2 million just for that one facility. And you can imagine, what the impact is globally when CAT's got 120 plus facilities. That's really big dollars, could have a huge impact on their bottom line. And that's just scratching the surface of what can be done. In this last example, it's just a great example when you say a picture's worth 1,000 words. Here it is. A customer had taken a delivery on a new manufacturing cell. They weren't getting anywhere near the promised productivity from the machine. So luckily, Freedom eLog was in place. You can see in the first quarter, January through March, their green time, their in-cycle time, was extremely low. It was less than 30% on average. Lots of yellow time, which means it was spending a lot of time in delay. But by having that data, by being able to drill into that data and understand what those delays were and what was causing those delays, you can see by the end of the second quarter, the in-cycle time more than doubled. And more importantly, they were able to sustain and continue to increase that green time throughout the remainder of the year. So not only did they increase, but they were able to sustain, and that's really important. You need to have a sustainable process. So we'll just wrap it up here, the summary of why it's so important to collect data. Continuous improvement programs, they really need to be part of your company's competitive strategy if you're going to be successful in this globally competitive market. All continuous improvement programs, whether it's Lean, Six Sigma, TPM, whatever it is you're trying to implement, they have to be based on data. They're all data-driven processes. We talked about the dangers of trying to make adjustments or tampering with your processes without making those decisions based on real data. You can actually make things worse. And while manual data collection is better than no data, it certainly comes with baggage. And so automated data collection is really the more efficient, most effective way to drive the data for your continuous improvement processes. And on that, I think we're going to wrap it up.
Great. Well, thanks so much, Pete. And for our listeners out there, Pete has agreed to stick around till the top of the hour and answer your questions. So let's see. Here is one, Pete, that came in from a listener. Oh boy, there's several coming in, so bear with us. Well, maybe you can start, Pete, by sharing with our, for our eMaint clients there that currently have a CMMS, what are some of the foundational data that any organization should be collecting in their CMMS to take advantage of a more automated, bigger data collection system, such as Freedom?
Right. So, the things you should be monitoring when connected, through rich digital or rich interface, in cycle, out of cycle, the alerts that are being generated by the control system, tooling data, downtime reason codes. Now, some of those could be automatically generated, but in many cases, there may not be something wrong with the machine, and so it's very important that when you're looking at a system to do your reporting and analytics, that it offers you a portal which allows you to supplement or augment the data that's automatically collected. And Freedom is one of those systems where you can select specific downtime reasons and give better granularity to what's happening on the machine if it's idle and there's nothing wrong with it.
Great. And also, we've had several people ask if they could get a copy of the slide deck to share with others. And again, Pete and 5ME have agreed to make a copy available. Just indicate you'd like one at the end of the survey. And here someone is asking, I hope I understand this question, what's the percentage of data collection time versus implementation on successful projects? I guess meaning, how long do you have to be collecting data before you start to see some of the results that you shared?
Oh, that's a really interesting question. I will say that in those instances where no monitoring is going on at all, and monitoring is now being put in most cases you're going to see a spike just based on some behavioral changes because people know that a monitoring system is in place. But if you're collecting data, I'd say within a week or two, you should have a good baseline of data so that you can really start digging into some of these reports, and you'll start to actually see some trends. As long as training has taken place, and that all the stakeholders are inputting the information as required, I'd say within a couple weeks you're going to start to see some real valuable data.
Excellent. We have some listeners that have some other pieces of software currently doing some form of data collection, for instance, tracking downtime delays, but it's done based on person or operator and not on asset. Do you also have integrations with other systems, or are you only collecting data right from the machine source?
So Freedom typically, we have typically connected and we monitor machines. We're not monitoring people per se. So, but we do have the capability of interfacing with other systems, like the slide I showed in which we're interfacing with MES, ERP, and CMMS systems. And that's really part of our core strategy. When we initially developed Freedom, the whole purpose was, let's drive maximum value for our customers by being able to connect with any industrial asset. And now that we've really conquered that, we're kind of mirroring that strategy only upwards and being able to connect with disparate software systems. Anywhere where we can add value by sharing our data, we'd absolutely be happy to do that, as long as there's web services or APIs or some form of tools in order to build the bridge between our two systems.
Excellent. Okay. And is there any limitation or constraint on the size of data being collected or the amount of data being collected?
Not at this time. I mean, the MT Connect protocol, we can stream the data. It's typically based on changing states. So, Freedom has a very light footprint from an IT perspective. While we are storing all of that data in the Historian, it typically is a pretty small footprint on storage when compared to other systems.
And what about with people that have some older types of machines, that may not be as modern, have all the digital interfaces? Is there still a way to, have you worked with clients like that, and is there still a way that they can take advantage of monitoring and data collection?
Absolutely. No data, no machine is too old, and so we absolutely have devised a way to connect with those older assets. It's called our FDI, or the Freedom Digital Interface. I believe there was a picture of it in one of the slides. But yeah, basically what we've done is we've created a hardware appliance on which our Freedom adapter resides, and we would connect with that older asset using discrete I/O. So that allows us to connect with, really any industrial asset regardless of age. It could be even an old manual asset or a manual process. We could still collect data from it.
Okay, good to know. Here's a specific question. We kind of like to tap your expertise regarding OEE. And is it a good idea to track OEE on specific equipment and per line? And a little clarification, in this instance, there's 8 to 10 units that have a conveyor, so many times the product exits the line even though a specific piece is down. And so, can you just share best practices on if someone is looking to measure OEE, sort of at what levels in the hierarchy you should be measuring?
Sure. I mean, yeah, and some of those really require the ability to drill into the unique circumstances. But we have the flexibility where you can look at those assets individually. You can look at it as a line. And so, I understand the scenario that from which the question comes. It could still be outputting a part even though one of the machines is down. And so we do have some flexibility there that would allow customers to, manipulate the way they want to see the data or they need to see the data in those circumstances.
Very good. We also were asked if some of our listeners have a historian or, a server in place that does some form of data collection, but perhaps not as robust as Freedom. Have you also integrated with that type of equipment, or again, just directly from the machine itself?
Typically, it's directly to the machines.
Gotcha. All right, and I don't know if you mentioned about Freedom. Is it strictly, as eMaint is, a cloud or a SaaS-based, or do you have other options as well?
Yeah, so our newest version, Freedom 4.0, which coincides with Industry 4.0, is based on cloud technology, and that can be deployed both public and private. We certainly understand that in many cases, when you're dealing with discrete manufacturers, they can be sensitive about data, and so we offer an option. We can certainly deploy the cloud publicly, or if that's not acceptable to IT departments, we could deploy within the customer's firewall, or what we would call a private cloud.
Okay, good to know. And are there any limitations on, I recognize our clients here come from quite a variety of industries and sectors, and they're all tasked with managing different types of equipment. Maybe you can just tell us what types of equipment this is best suited for, if there are some better than others, or can
Right.
you characterize the type of equipment where you can see the kind of results that
Sure.
you've been speaking of?
And we've connected to a variety of different equipment over the years. CNC-based equipment, PLC-based equipment, robots, manual machines. So the applications have typically been on the discrete manufacturing side, anything from metal cutting machines, mills, lathes, grinders, hobbers, you name it, anything to do with metal cutting. PLC-based automation, washers, testers, a variety of different robot brands, welding cells, ovens, autoclaves, composite laminating equipment, carbon fiber, either tape layers or fiber placement machines, all sorts of different equipment. There's really no limit.
Excellent. Well, good to know. Well, I'm afraid we're getting to the top of the hour, and I want to be respectful of everyone's time. So again, I'd like to thank Pete and 5ME for putting together this presentation and kind of opening up everyone's minds to the possibilities here with, in this day and age with integrations and monitoring, and capturing key information. And I hope everyone took away something that they can apply immediately. And again, we don't want the dialogue to end here, so please, when we're done with the at the conclusion of the webinar, we'll give you a brief survey and let us know how we did. Let us know what additional topics you'd like to hear about from industry experts like Pete, 5ME, or others. We want to make sure we're sharing with you solutions to the challenges that you're facing every day. And again, Pete will be sharing a copy of the slides of today's presentation, so if you or your team have additional questions, please don't let the conversation end. All right, so again, thank you all for joining us today, and thanks to Pete and all the folks at 5ME, and to our listeners, and have a great day, and we'll see you all the next time.
Thank you, Rona.
You bet.
Bye.
Take care.